Foundation. Igama lami ngu-Innocent Wawambai, futhi ngizokwethula i-Physical Sciences njalo ngoLwesibili kusukela ngo-4 kuya ku-5. Ukhozi FM luzozethula lezi zinhlelo ngo-9 kuya ku-10 ebusuku njalo ngoLwesine. Ngangena ku-Facebook ekhasini lethu le-Go Digital SA Movement noma ku-YouTube Go Digital SA Foundation yethu. We want to move on from where we left over last time. Sasikhuluma nge-reaction rate. So from there, just to remind you of a few things, esakhuluma ngayo. Sasikhuluma nge-mechanism of reaction. Sakhuluma ngokuthi for a reaction to take place, kufanele nama reactant azoshayisana ukuze kube ne breaking of bond and forming of new bond. Sakhuluma nge-collision theory. For a reaction to take place, ama reactant have to absorb a certain amount of energy. Bese leyo energy izokwenza ukuthi ama bonds abe broken, bese kufomeka amanye ama bond amasha. That will give you what? A product. That is a new substance. Right. The collision theory. Sathi ukuthi mase collide ama substances, ama particles lawa for ama reactant. There are conditions ukuthi leyo collision leyo ibe effective. It's only an effective reaction that will lead to a reaction to take place. And the reaction to take place, udinga ama bond or reactant to be broken, mase kufomeka ama bond amasha. That one will just be happening only if a collision is effective. And ama conditions are akhona ati particles must have sufficient kinetic energy. Then beside that, you also have a correct orientation. Is just an example that is given there. In a particle, a substance, this is another substance. Those two substances, they are moving, a random motion. Lama substances lawa ane kinetic energy. Then at this point, ayashaisan. Right now, this collision that takes place here must have what? Sufficient kinetic energy. Njengoba le particles ishonangala, le ishonangala. Mese kuyashayisana. This collision here has to be effective. And must it be effective, it means a collision, the particles must have what? Sufficient kinetic energy for to go in a correct orientation. The way orientation elana, I enzuguti a bond, le bond if broken, normal le bond if broken. So shaisana, mese kubiyele move, so bounce back. So these particles will bounce back. It simply means that the collision was not effective. Gobani, because it did not lead into breaking of bond and forming of new bond. We have the second scenario here. Same thing. The collision here did not lead to a breaking of bond and forming of new bond. Even if kinetic energy, particles was enough. The problem was what? A correct orientation. So these two examples here are giving us a collision that is not effective. It is an ineffective collision. So no reaction will take place here. Then finally, example ela. We have this particle. We have with the previous one. So this one will lead into breaking of bond. Angchabongala kona le particle the blue one, right? Then you have the red one. So a collision that will take place if you have sufficient kinetic energy, then bond will be broken. And suppose we have now another bond between the red and the blue, while initially this was just all red. Now, due to this effective collision, so for that effective collision, it simply means that we had the two conditions. The first one is sufficient kinetic energy. It means the particles collided with what? Sufficient kinetic energy. But that is not enough. You need what? A second condition. That is what? A correct orientation. Last Tuesday, correct orientation. Right. The other thing, sakhuluma energy will be absorbed. Gala kuma reactant, energy will be absorbed. Then to form a product, energy will be released. Then for that one, sakhulumange exothermic ne endothermic reaction. Funa sibuyelinga. Kona le graph le part le ikombisa energy yama reactant. Goba site ama reactant, they are always in that random motion. So singati let's have example. Sabe soti sino H2 plus O2 sneaker H2O, right? All these are gases. Now you have a reaction like this. The equation is balanced. So this represents energy of the reactant. So it's not that reactant are now energy. They do have energy. But product now has an energy. So what we have to look at is for this reaction to take place, this reactant here, the bonds in the reactant have to absorb enough energy so that this bond will be broken. So the energy that will be absorbed, and we call it what? The activation energy, right? So this is the energy that will be needed for the reaction to take place. And we know that for the reaction to take place, we must have what? An effective collision. And to have an effective collision, particles must collide with sufficient kinetic energy and also with correct orientation. So when you are looking at this, we have this part, activated complex. Activated complex. This is a part where it's a transition, between a reactant and a product. So if we have to move from this side to that, now this graph is going up. That is the energy that is being absorbed. Ama bond, ama reactant have to be broken. Now, when the bond is formed, when the new bond are formed, energy has to be released. This is the energy that has to be released. Si form lama product, right? So how do we get this activation energy? We just take what? The energy at the activated complex, the energy yama reactant. So if we have that, you can be able to calculate what is the activated complex. So that is so easy. So Singati need to calculate the activation energy. The activation energy. So we look at the energy at the activated complex. Right? Density minus the energy yama reactant. Right? Once we have that, then it will give us what this difference here, and that is the activation energy. Now, and since Sugangala from H2 plus O2, H2O, right? It is a forward reaction. Now, kungeza ukuthi le reaction ibe reversible. It means if you are in you have these particles in a container. Once you have more H2O, they can be broken into what? H2 and O2. Uyibona kanjani reversible reaction? Uyibona ngama arrows awu-2. Eyodwa ekhomba ngala, that is your forward reaction, enye ikhomba ngala, that is your reverse reaction. So uzobona ukuthi i-activation energy for the forward reaction is different to activation energy of the reverse reaction. So if this CD here, these particles, they behave as ama reactant, afunusniga ama product, that will be now AB. So reaction is shonangala. So we need to break this bond, and to break the bond, energy must be absorbed. So Ithala from here, sinyuke, sitoleleo difference between energy of reactant. This time, now this part is our reactant. Gala, we have ama product. So this becomes the energy of the activation energy. Now, the difference between the energy of the reactant, the energy of the product, it's what we have here. We call it what? Delta H. That was called the change in the enthalpy or the heat of the reaction. Right. Now, when we look at this graph, the energy yama reactant is greater than the energy of the product. So when we calculate a delta H, we'll find that the energy of the product minus energy of reactant. So in that case, you'll find that the energy reactant is greater than the energy product. So our answer will be what? A negative answer. In that case, we'll say energy is released. So the graph, the forward reaction, represent what we call the exothermic reaction. We call it the exothermic reaction. So an exothermic reaction is a reaction where the energy is released. Now, sometimes learners confuse, when you are under pressure. What is the graph? When you are writing your exam. Right. When you have a graph like this, right? Let's forget about the other one. You have this graph here. Now, how do you know whether it is an exothermic or endothermic? I'll just share an example with one of my learners, White and Moto, Hilux. Yeah, the Hilux. Yeah. So this helped the learner just to know Mabugi graph ability. Okay, this one is for exothermic. Now, the energy of the reactant is high. What to low high? Then the energy of the product is low. Then what you X? X for what? For exothermic. So why it's all around dialogue. So never forget about that. More on the high lax. So you start from high energy going to low energy. X for exothermic. So I hope you won't be forgetting about this graph, kind of graphs again. So the opposite vele kuzobaini endothermic reaction. So this was just to remind you about what we learned last time. Then sakulumange reaction rates. The reaction rate. Now for the reaction rate, we said that the reaction rate will be the change in the amount of the reactant, the change in the amount of the reactant or product per unit time. Now, we said that velocity amount is just that we don't know which quantity we are using to get what the amount. Now, when we are in chemistry, we usually know that when we want to quantify, we try to need the amount of any the amount of the substance that we are using, right? We use what? The number of moles. The number of moles. Because this one is the one that will help us to do our calculations to quantify these substances in chemical reactions. Now, the other thing, when we're talking about the amount, it always depends on the phase of our reactant, right? For example, last time, zinc and HCl that are reacting. This one gave us what is zinc chloride plus hydrogen gas. So this part here, the zinc is solid. Aqueous lo HCl, the aqueous lena, this one is a gas. So maskulumangé amount, we try to look at into izo a number of moles. So when you have the solid, for example, solid is ngakulumangé mass, right? Because yazi ukuthi mass will send us to number of moles. Because mass is what? Is the number of moles times the molar mass. Because zinc is solid. Then lana sine aqueous. The aqueous solutions ngasebenzisa any concentration. All of these, they express what the amount, the concentration. Go sine aqueous solution. Quick concentration, it's also related to number of moles. So we know what the concentration is number of moles over a volume, right? Now, when we have this one, still cinema aqueous, so concentration will be there. Then we have what? Gas. The gas, we can use what? Either the mass or the concentration, but also what? Also the volume. Because remember with Avogadro, it said that 1 mole of any gas will occupy what? The same volume if they are all under the same conditions of temperature and pressure. And Kakreten Sakuluma at STP. So we had what? The molar volume. So we know that the volume of a gas will be what? The number of moles times the molar volume. So these three quantities here, they represent what? The amount. Amount. So the change in amount, so it can be the mass if you are changing the mass. So the change in mass per reaction rate, change in mass per unit time, change in concentration per unit time, change in volume per unit time. It always depends on which quantity you are dealing with, right? And that will also affect what? The unit. So we don't have a 1 unit for reaction rate, per unit time. So if mass, the mass is expressed in grams, right? So our reaction rate will be expressed in what? In grams per second. Multi-7 second as the unit of time. Kotoma 7 minute, it will be grams per minute. Now, if we have a concentration, the unit for the concentration is what? It's mole per decimeter cube. So a reaction rate will have the unit as mole per decimeter cube per second. Multi-7 second. Kotoma 7 minute will be mole per decimeter cube per minute. Kanjalo. Then the other one is the volume, right? If 7 cubic decimeter, so the reaction rate here will be expressed in what? In cubic decimeter per second, normal per minute, and so on. Right. So that's how we have to calculate a reaction rate. Then another thing, in order to calculate a reaction rate, right? Now we need to know what is needed so far. Kona examiner if the exact answer. We exam guideline, a reaction rate is defined as the change in the concentration of reactant or product per unit time. So ungayisebenzisa leyo definition, unless if they want to be specific. Ukhuluma ngani? Are you talking about the mass? Noma ukhuluma nge concentration. So in that case, you have to define it according to leyo quantity okhuluma ngayo. So if it's a mass, uzothi the reaction rate is the change in the mass of the reactant or product per unit time. Multi-volume, uzothi reaction rate is the change in the volume of the reactant or product per unit time. So I hope we are all fine for this one. Certificate, when you are calculating a reaction rate, the way things are changing, right? So when you mass in a reaction like zinc, zinc, then you have HCl, right? That is an aqueous solution. Then we have zinc chloride, aqueous plus H2, we guess. Now, when the reaction progresses, the amount of zinc will be decreasing, right? The amount of HCl now is decreasing. Ngoba sisebenzisa is zinc and HCl. So these two are the one that must collide. So ama particles of zinc will have to collide nama particles with HCl. Ukuze formeke le product zinc chloride ne hydrogen gas. So now is on it. Now, how do we calculate the rate of reaction? Last time skulume kama reactions out two, ama rate of reaction out two. The first one, it's when you are calculating the average rate of reaction. Rate of reaction. How do you calculate this one? You don't worry about what is happening during the reaction. You only worry about the final amount minus, right? The final amount. Remember, man kuluma nge amount angisho just amount. Kuluma either about mass, normal concentration, normal volume, minus the initial amount. Initial amount, right? Over change in time, right? Now, most of the time, learners are losing marks by not writing the change in time. Without checking that it's also the time. So it's final time minus initial time. Right, that is your average rate of reaction. But ungenzeka futhi ube ne instantaneous rate of reaction, right? Like for this graph, for example, let's say lokhu kuzowehla kuze kuphele mhlambe after 5 minutes. Yabo delta T wethu is in minutes, right? So we have this amount. Let's say somebody is 3 moles for zinc. So we find that the initial amount of zinc is 3, the final amount is 0. Goba zinc pelile completely, right, in the reaction. So to calculate this change in the reaction, the average rate of reaction, so we get final amount. The final amount is 0, so it is 0 here, minus the initial amount is 3 over the initial, the final time 5 minus what? Minus 0. That is your initial time. Please do not leave this minus 0. Though monga falanga fellows told 5. Koto 5 you did not show what it's also the change in time. So multi minus 0.5, 5 minus 0. Then you have what? Your rate of reaction. Those of negative 3 over 5. Right. So you get what? Your reaction rate. This one get average reaction rate. Now, kungenzeka ukuthi utole you ask to calculate a instantaneous rate of reaction. Right? Mangibhala ukuthi RR ukwazi ukuthi rate of reaction lengikhuluma ngayo. Right? Instantaneous rate of reaction. Asibuyele ngapha. The instantaneous rate of reaction. Right. Now, when you calculate the instantaneous rate of reaction, they'll tell you exactly at what point, right? Like if I take our graph as it is, 5. Now here we have 3. So it's cut said sugala 1 minute, 2, 3, 4, 5. Then if Kutiwa, what is the rate of reaction at time 2 minutes? Shoguti sila. Right? Now you can use the graph and check what is the number of moles on this side. Now funuktola in instantaneous rate of reaction. Now go with formula, we could see Guti must change in the amount. That is the change in Y. And over the change in time. The change in time we met to x-axis, that is the change in x. This one we met a gradient. The rate of reaction is the gradient. Ingakutola a gradient even negative more 7 zisa ama reactant. The same gradient will be positive more to 7 zisa ama product. So when you are calculating this instantaneous rate of reaction, and so you have only 1 point, our change in Y or change in S because it's just 1 point. So what you do in that case, would have a tangent. That line that will just intersect this one at 1 point. You have a straight line. Now, masun a straight line, sunga keta, no maipi point lana. So with there, you can now have what? 2 points. Masuna ma point out 2, obviously gradient to Yagwas we told. That is the instantaneous rate of reaction. Zobono guti to calculate instantaneous at 3, right? Let's say at 3 minutes. Gagi safana an instantaneous reaction rate at 2 minutes. Gobo zobona as the reaction progresses, the rate of reaction here decrease. So even the slope, right, it's also decreasing. So that is how you calculate rate of reaction. So we mentioned that. Now, today our main focus, as we said last time, will be on factors that are affecting what? The rate of reaction. Factors that will affect the rate of reaction. So remember, for a reaction to take place, particles have to collide, right, effectively, right? Factors affecting a reaction rate. Now, anything that will affect a collision among particles, then that one can affect a reaction rate. Now, the only thing you know is if we have a shorter period of time for a reaction to reach completion, that reaction is faster, the rate of reaction is high in that point. Now, don't confuse the time increasing in time and decreasing in time. Anxiety reaction rate is the change in amount, right? Amount, change in amount over delta T. They are inversely proportional. If you have to increase the time, reaction rate is a decrease. So when you have a graph, you know this graph here has a higher reaction rate. From the example, I'm a graph out too. Right. Let's say the first one, Nancy graph CB out P. Then there is another graph. Now you're under the same condition. Now itiranje. Right. Now Kutiwa, this one is Q. Now, which one between these two graphs represent what? A faster reaction. A faster reaction. Now, we need to know the one that has what? A greater rate of reaction. So your answer here has to be referring to a graph. So when you look at this graph, mathematically, E gradient gap P is higher than the gradient Q. The next thing, P ufike ngokushesha at completion, while Q uthatha isikhathi. Right, angisho ukuthi isikhathi siya increase. Let's say lana sino 3 second, lona uno 5 second. Kusho ukuthi P reach completion at 3 ngesikhathi esincane. So it means once we decrease lo delta T lona, reaction rate izokwenza njani? Izo increase. So when you see the shorter period of time, it simply means that you have what? A higher rate of reaction. The other thing, you talk about what? A gradient. So if you have to answer a question that is related to a graph like this, just look at the gradient, look at the greater slope, so Krumange gradient, then you also look at the time, right? The shorter the time, the higher the reaction rate, right? Or the steeper the gradient, the higher the reaction rate, right? Now, we talked about lama factors. Let's just mention them. Then sobono guti factor kanjani a rate of reaction, right? Now, our 6 lama factors. Funua kwanema wonke lana, so that we'll go through each one by one, right? Factor number 1, skalenge temperature. This is one of the factors that affect what? The rate of reaction, right? The first one, you have a temperature. How does the temperature affect what? The rate of reaction? Maskulumange collision theory. Remember, a reaction will only take place masinama effective collision. Ama particles have to react. Manje temperature affecta kanjani ama particles. Goba temperature is defined as average kinetic energy ama particles. Once you increase the temperature, you increase any speed sama particles. So temperature dila nani ne speed of particles. Maskulumanga speed is kulumangani the kinetic energy. I hope nyagwazi logo. Angisinyazi ukuthi kinetic energy is the energy an object has due to its motion. So mau increase speed sama particles kuzokuthi ne kinetic energy iso increase. And our main focus uban ama particles, because these particles are the one that must collide, right? Okay, have that in your mind so that you know how the temperature affects a rate of reaction. Ingoba a temperature affects any speed sama particles, and the speed ihamsana nani ne kinetic energy. And site uze ikube an effective collision, particles must collide with what? Sufficient kinetic energy. So what must increase the temperature, see increase the kinetic energy yama particles. Ingako temperature is one of the factors as affect a reaction rate, right? As buge factor SB, concentration. By definition, in concentration, you have the number of particles per unit volume, right? The number of particles per unit volume, right? Now, maskulmange number of particles. Kushokuti mawuti ama particles maningi kui volume. Kushokuti kuzoshaya sana. Right, so there'll be what? More collision that will take place. Goba maning vele per unit volume if we increase the concentration. Right, that's why a concentration now will have what? An effect on what? On a reaction rate. Then the third factor, pressure. Pressure. Here in pressure. By definition, number of collisions between the particles and also with what? With the particles and the surface of the container. So sikulumanga number of collisions, right? Collisions of particles. So uyabona ukuthi le factor nayo affecta ini ama particles. So khuluma nge number of collisions, ama collisions enzekayo kwi container in which a reaction is taking place. Then number 4, sikhulume nge surface area. Surface area. Right. How does the surface area impact on a reaction rate? Just that this surface area is the state of division. So the surface area is dealing a number of particles that are exposed. Number of particles that are exposed. Right. Now remember also a reaction particles must collide. So if we have more number of particles that are exposed, as well as collide, vele kusho ukuthi ne reaction yetu is over fast. Then the next one, number 5 will be what? A catalyst. Skulmange catalyst. By definition is 10 in a catalyst. The catalyst is that substance that speed up a rate of reaction. But what does it, how does it speed up the rate of reaction? Ingoba a catalyst, it lowers in activation energy. Lowers the activation energy. And so in order to, for the particles to collide, they need what? This activation energy. So if the activation energy is high, so only few particles as of figure lab. But if you have a lower activation energy, more particles will do what? Will be able to react effectively. Then the is a nature of the reactant. Nature of reactant. Right. On this one, we cannot change it. Goba kamisana ne nature ye reactant. So if gisebenzisa zinc is a transition metal. Noma ngisebenzisa magnesium is the alkali earth metal. And so reactivity zinc ne magnesium akufani, naturally akufani. So maskuluma nge nature of the reactant, unless you've changed one substance to another. Otherwise, if you still have the same zinc, nothing will happen as a nature. Right? So we've named all of them, and let's try to see how you can now be able to explain this using what? The collision theory. Because the problem is sometimes abafundi can understand umbuzo kodwa bangazi ukuthi fanele bathini when they have to answer the question. Right. Now, what I want to give you as an advice, I'll take each one of these factors, then we'll start talking about all of them at the same time, so that you can be able to see them, right, while we are explaining. No mounting pinning so that we don't have too much papers here. So the first one is kulumange, the temperature. Number 1 low. Number 2, cite concentration. Number 3, cite pressure. Number 4, cite surface area. Number 5, cite a catalyst. Then number 6, cite nature of the reactant. Right. Now, what you need to know here, which factor will affect which phase. Yabo we temperature ngala ngitiniti all. Yabo temperature inga affect no main. Mau increase the temperature value, I increase for all the substances. The concentration The concentration will affect only what? Aqueous solutions, nani, nama gas. For the pressure, local can only affect what? A gas. Yabo? Then in the surface area will only affect what? Solid. The catalyst can affect what? All. Then a nature of reactant lapo, unless we are changing, instead of ukusebenzisa HCl as an acid, mhlambe singasebenzisa nitric acid, angisho kwenye acid ayifani nale yaseqaleni. Masithi HCl, for example, that one is a strong acid. Noma sibenzise acetic acid, even though they are both acid, but uyabona is strong acid, the other one is a weak acid. Kusho ukuthi ne reaction yazo ngeke ifane in terms of time. So just bear it in mind. Like in our example, for example, sasikhuluma nge-zinc solid, a reactor nani, no HCl, or what? Aqueous, right? Zinc chloride and H2. What can affect a reaction rate? Izinto zenzeke ngala ngokwe reactant. So lama factors lawa sibuka ama factors that can only affect lama reactant. Ngoba kufanele ku react lama reactant ukuze kuphume I product. Right? So masibuka ngala sibona ukuthi khona I solid la. So masibuka I solid, the other one is an aqueous solution. So looking at this, temperature can change rate of reaction. Ngoba sithe temperature ingena yonke indawo. Concentration inga affect nale rate of reaction ngobani kune aqueous solution. Yabo? Pressure angeke yenze lutho ngoba gas ila kuma product. We only want something that will affect ama reactant. So pressure can never have an impact on this reaction. No more increase and no more decrease the pressure, it won't have an impact. Ngoba we don't have a pressure lana asina a pressure ngala. So pressure does not have an impact kule reaction. Surface area ingakwazi ngoba sinani sine solid la. Then catalyst, yeah. Sithe catalyst ingena na yonke indawo. Masifaka catalyst nje, it will be speeding up what? The reaction. Right? So with nature of reactant lapho ke until we change. Kodwa makusanjalo izinc ne HCl, nothing can change. The speed, the reaction rate can change only instead of zinc, sesebenzisa ini sekuyi magnesium solid that react with what? With HCl. Now this becomes what? Another substance. Any reactivity ehlukile kune reactivity yani ye zinc. So my point is, mawuphendula lo mbuzo kuthiwa explain what must be in your answer. That is my main point. What you need to include in your answer. For all of them, it's gonna be the same thing. So that pressure, what should I talk about? Because sometimes you understand the concept. I will need examiner lento ayifunayo. So in all of them, pendula foot in point form. Uti bullet number 1. Ye ufuna wisho the bullet number 1. Masikhuluma nge-temperature, no my concentration, no my pressure, no my surface area, no my catalyst. Sikhuluma ngani? Asiqala sikhulume nge-facts. Yabo? Masikhuluma nge-fact kusho ukuthini? If you increase the temperature, the rate of reaction will increase. Noma makusebenzisa concentration will be if you increase the concentration, the rate of reaction will increase. If you increase the pressure, rate of reaction will increase. If you increase its surface area, the rate of reaction is will increase. Mawufaki catalyst, the rate of reaction will also increase. So effect leyo uyibambe kanjalo it effect. Kusho ukuthi ma u decrease and still the rate of reaction is decrease and right. So bullet number 1 effect. If temperature is increased, rate of reaction will also increase. Bullet number 2, ufanele include the bullet number 2. Bullet number 2 ihambisana ne definition. Noma we are explain leyo factor leyo. Maguti temperature, any temperature, right? It's the measure of the average kinetic energy yama particles. No maskuluma concentration, it is the a number of particles per unit volume. Masikhuluma nge-pressure, sikhuluma nge-number of collision, right, per unit volume. Masikhuluma nge-surface area, sikhuluma ngani? Nge-state of division. Sikhuluma ngama-particles that are exposed. Masikhuluma nge-catalyst, sikhuluma ngani? Sikhuluma activation energy that is lowering, right? So angithi uyabo ukuthi sikhuluma nge-fact mase sithi i-definition. I-definition sidefine lama factors lawa sinawo. Bullet number 3 uthi how, okay, I think it's 1 lana, it's 2, it's 3, right? How 2, right, is affected by 1. What do I mean? What do I mean when I say how 2 is affected by 1? So I define the temperature is the measure of the kinetic energy. Number 2, number 3, by increasing, right, in temperature, speed here increase, no my kinetic energy here increases. So see related effect nane definition. So if see increase in temperature, speed so increase. Maskuluma concentration. So if we increase in concentration, right, number of particles per unit volume is so increase. Maskuluma pressure. If we increase the pressure by decreasing the volume, particles, the collision number of collision will increase. If we increase the surface area, particles amaning that are exposed. If we add a catalyst, activation energy a low, right? So that is how you need to explain that. Then number 4, it's now when you have to refer to effective collision. So the number of effective collision. The number of effective collisions. Now, ngoba sikhuluma nge-reaction rate, ungakhohlwa lokho per unit time. I emphasize on that. The number of effective collision per unit time will do what? Will increase. And maseku increase a local kushogutinani, the rate of reaction will also increase. Please have that in mind. So, makutiwa explain, you have 1, 2, 3, 4. Ngeke ukawuthola 4 marks noma 3 marks or dingagalani, right? So I hope I've covered and you guys will be now ready to answer any question regarding what factors affecting the rate of reaction, and you go back to refer to what we collision theory. Go by collision theory, sitting effective collision. For effective collision, we need what? Particles to collide with sufficient kinetic energy and correct orientation. So the more effective collision see now, right, per unit time, the reaction will be what? Will be fast. Then, the last thing I want to mention here after talking about this one is how Lama factors, right, were dealt with by a scientist called what? Boltzmann. Boltzmann wavela kufaka nge-graph. Funukaza uguti, how do we look at these factors that are affecting what rate of reaction? Boltzmann, right? Boltzmann, Maxwell Boltzmann, distribution curves, right? So the understanding yake ihamba with the temperature. When a concentration, then zokuluma ngani nge catalyst. So I graph yake ithi. Now, if this represents the energy, right? Ngalas in a number of particles. So lama particles lawa can be put under a certain graph. This graph here contains what? Lama particles lawa are reactile. right? Now, for them to react, they must have what? They must have energy that is greater than the kinetic, the activation energy. Now, it's activation energy, Ella. So by looking at this graph, kushokuthi only lama particles angala azo react ngoba anani energy enkulu kune activation energy. Wonke lama particles lawa awanayo leyo kinetic energy. So masi increase a temperature. Uzobona ukuthi lama particles, some of them ngoba sithe by increasing the temperature ngisho lama particles energy yama particles ya increase. Kusho ukuthi most of ama particles azoshifta azosuka ngala gaga left ashone gaga right. Mase I graph izoshintsha I shape ibe nje. Right? And manje these particles lawa out to 1, 2, 3, 4 in our example say shiftile ngaga right. So now you have what our 4 aedegile sekuna ama particles amaningi ane energy enkulu kune activation energy. Ilapho kwenza ukuthi kube ne reaction ibe fast. So the red one represents a temperature 2. Cut the blue one is temperature 1. So singathi ukuthi temperature 2 is greater than temperature number 1. Right? That's how Boltzmann could explain that. Then for concentration ihambisana nama number of particles are present in a surface in a container. Now until we still have our activation energy Ella. Right? Now we see nama particles acon. Now must increase the concentration sense and see increase the number of particles. Show to maningi this time. Show to must increase ama particles. Then gishone graphite izotiranje. Goba se sinama particles amaningi manje. Goba se increase in concentration. About by increasing concentration, se sinama particles amaningi on the right side. Right? That is how you understand it. So the blue one represents the concentration 1 and the red one concentration 2. So singati concentration 2 is greater than concentration 1. Then the last one, a catalyst. Right? The last one is the catalyst. Now, the same graph as given initially. Right? The same graph is sugangala ipete ani ama particles. The particles are there all over there, right? But not all of them are energy enkulu kune activation energy. Sesine activation energy ela. So these are only the only particles are energy enkulu kune activation energy. Masfagi catalyst, site catalyst yehlisa activation energy. So the activation energy is a shifter gaga left. So our new activation energy is ila at this point. So about to message is activation energy. Nala ma particles lawa. Enga gwazanga nje ukufika ku energy activation energy ngaseqaleni. Now they can now have what activation is. Akwazi ku reactor now. So you have now what more particles that are reacting, right? So bafundi, I think this one is just a summary of what you need to know the reaction rate, right? Now, I just want to check quickly when you are dealing with questions. There are questions that are akulumangama graphs. I think that one I've addressed. Mau explain ubuga I gradient ubuga futi ne scat. Then kona enye kuniga equation izokuniga sambe graph. Yabo izokuniga sambe graph. I hope nizokwazi ukubona lo izokuniga no table. When you look at this one, kutiwa time 0, 1, 2, 3, 4, 5 iskati leso kutiwa in minutes. Mese kuti volume of CO2 0 lana 0.5, 0.75, 0.9 1, 1, 1. Angisho mase kufika la ukuthi 1, 1 sekuyaphinda 1 kusho ukuthi i-reaction ngalesi iphelile. I-reaction iphele ngo after 4 minutes. Yonke into ezoqhubeka ngala isikhathi i-concentrate i-volume izoba 1, 1, 1. So i-reaction ngal iphelile. So when you have to calculate a reaction rate, usebenzisa le part le u4 minutes, high u6 minutes, usebenzisa lo 4. So a concentration lapho that volume was 1. So uzothatha le volume length at 4 minutes, that is your final volume minus initial volume per unit time. Change in time is 4 minus 0, you have it. You don't consider all the other times that made what the volume to be what? To remain constant. So that is one thing I wanted you guys to be able to do. Now, mawubuka a reaction rate, zikhona indlela okwazi ukuchecka ngayo a reaction rate. The first one, ubuka the change in mass. Makune change in mass of the container, right? Uyawazi ucalculate a reaction rate. You can also have what? The change in color. So you are looking at the change in color per unit time. You can also look at the formation of a precipitate, right? Precipitate. Right, so you have that one. Now this will help you to do what? To be able to measure the rate of reaction. Now, if a reaction is releasing a gas, for example, right? And you can have a mass meter here. Mesufaka I container yako lana ino zinc in a HCl. Mase ku-reacta kuphuma ini u-H2. H2 is a gas. Let's say masically reaction is mhlawumbe ngo 2 grams, just an example, right? Or 20 grams. When the reaction takes place, makufomeka H2, it's a gas, izowenza njani? Izo-evaporate. Ngesikhathi evaporate, le mass le izoba inzani, iya decrease njalo. So you can check the rate at which this mass is decreasing per unit time. And you are ukusebenzisa leyo change leyo to calculate what? The rate of reaction. Kungenzeka futhi, instead of doing that, ivale le container ne stopper, yabo? Then ufaki pipe izosuka la iye kwinto syringe like, right? Syringe sinama divisions here. Yabo mawufaki syringe, you'll find that gas leo H2 mase iphuma ngala izohamba ngala izogcwalisa le syringe. By going this side, it's pushing a syringe, so uyakwazi ukuchecka njalo urecord ukuthi qale ngo seku 1 mil, seku 2 mil, u3 mil. Now that change in volume uyakwazi urecord that per unit time, and lokhu kungakusiza futhi ukuthola ini a reaction rate. The other one is when there is a formation of precipitate. Ungathatha ipaper lana ubhala X omkhulu lapho. Then you put a clear substance. And so clear ungakwazi ukubuka from here uzobona ukuthi you can see the X. In reaction mayenzeka, you find that iyashintsha color, precipitate. Now you can be able to find that at the end awusaboni lo X lo phansi na. Kusho ukuthi reaction yakho senze njani siphelile. So that is the precipitate we are talking about, noma the change in color. Right? So learners, I think we've covered everything that need to be covered. Sotola futhi isikhathi masenze revision, sibuke different questions. Sibone ukuthi okay kuhamba kahle, and we wish you guys will do well after attending our lesson. So thank you for today, and let's meet again, same time, same place next week, Tuesday. Thank you.